Continuity of a function. Let us look at the definition. A function y equals f of x is continuous at x equals a if limit x approaches a minus, which is the left hand limit of the function at a, and limit x approaches a plus f of x are equal, and then also the function is defined at that point and all these values are same. Then we say that the function is continuous at x equals a, otherwise it will be discontinuous. Take an example. Given function f of x is defined like 5x minus 3 when x is less than 9, or you can say in interval notation, tip infinity to 9, open parenthesis, because it's less than. And then it has another part when my domain is x greater or equal to 9, 4 over x plus 4, or you can say x is in the interval 9 to infinity, 9 inclusive. So we need to check these two limits. So first we look at this limit. X approaches 9 minus, that means left side of 9. So we'll do this one. We put 5 times 9 minus 3. 45 minus 3, that gives you 42. Now, right hand limit, when x is bigger than 9 or equal to, so when I'm talking about limit, I consider greater than 9. So plug it here. You have 4 over 9 plus 4. So you get 4 over 13. Now if you look at these two values, they're different. Immediately we say that limit x approaches 9, f of x does not exist. And we have two different values here. So in this case we call it jump discontinuity. We take another example. In this case, my function fx is defined as x squared minus k, where k is a constant. X is in the interval negative infinity to 7, open. And when x is between 7 to infinity, 7 inclusive, or you can say here x is greater or equal to 7. In this case, x is less than 7. Other way we can explain. Now we need to find k so that this function will be continuous at 7. So we need to do these two things. So which is 49 minus k, and then when x approaches to 7 plus, now here replace your x by 7. So for continuity, we know that these two limits should be same. We just write 7k plus 3 equals 49 minus k. Now simplify, you subtract 3 both sides and add k. So you get 8k equals 46, 49 minus 3. So then what will be k? So your k will be 46 over 8, divide both sides by 8. Now you can further simplify, 23 over 4. So this is the k value so that my function will be continuous. Thank you. We take example number 3. This is a piecewise defined function again. So first f of x is defined when x not equals 0 or 3, like this. 4 over x minus 3x minus 12 over x squared minus 3x. Let us look at what happens when x equals 0 at this. You may notice here that when x goes to 0, this part is infinity, and then minus I have some other here. So we cannot just put direct, so let's simplify this first. So when I simplify with the common denominator, you can see that you get common denominator x times x minus 3, in this 4 times x minus 3, and then other side will be like negative 3x, when you distribute this negative, plus 12. So further simplify. I need some more space, so go up here. So you can see that it's coming out like 4 times x, 4x minus 12, and then negative 3x plus 12. So negative 12, positive 12 cancelled out. I have here 4x minus 3x, just x, and then x times x minus 3. So x again cancelled out. We get 1 over x minus 3, and still we are carrying our limit. So limit x goes to 0. Now when you plug x goes to 0 here, you have negative 1/3. You can put limit in front. So negative 1/3 is the limit of this function when x is 0. So we got the limit. Now if you look at what happens, I got limit x goes to 0, f of x is negative 1/3. So limit exists. Now x equals 0, that is given 12 here. If I just redefine my function here by negative 1/3, so then this is continuous. When f0 is negative 1/3 as a value here, we can make the corrections. Then we say that for the value of the function, negative 1/3 will make this function continuous at x equals 0. Let us look at what happens for x equals 3. I'm just taking the same result I had before. When I was checking this one at 0, this whole thing, when I simplify it, I have got like this. So now x you cancel out. Your limit comes out like x approaches 3, 1 over x minus 3, and you can easily understand that the limit at 3 does not exist because you have a vertical asymptote at this. So it's very clear that this function doesn't have continuity at x equals 3, and we are done.